So hello everybody. In here I'm also going to show you how to use the code that I'm providing you in Visual Studio. So in order to do that, you will need two things. One is CMake and the other one is Git. So Git is a self-evident because actually the code is provided as a GitHub project, and also because you will need also to pull out of some modules, because actually instead of replacing all the code from external repositories and just added everything as a submodule here. So we're going to use the mathematical library from OpenGL specifically. And therefore the other thing is that you will also need CMake, because I'm providing everything as a Linux-based project, but you could also open that and run it in Windows using Visual Studio if you just use CMake for create a Visual Studio project. So that's what we're going to do now. So after installing Git for Windows, then you will have a terminal, something just like this, and then that is actually saying that you're in the home folder, so is the home folder of your current user, so it's just on users and your username. And then after cloning the repo, you'll have the code available. So if you just go in here, you will see actually a lot of code that is provided in here. But anyway, if you go to the submodules, you will see that that is empty. So in order to make that non-empty, then the thing that you will need to do is to just do git submodule update in it. That will pull also the other repositories and clone them in the current folder, and after we're done with that, then you will be able to create the CMake project. So now it's doing the hashing for checking if the clone is correct. It's fine. So now you could also freely run the project. So as you see here, you have that the path is in C users, media, notes and programming. So that is the folder where the project is. So you just need to copy and paste where the folder is. So just remove this apex. Yep. And then after doing that, you will need to configure, because actually it's going to check the platform dependencies. So you need to tell that you want to create a Visual Studio 16 project and you want to compile, for example, for a 64 architecture and just using everything as a default. So after generating that is just checking all the compiler information from all the projects. You will be seeing some warnings, but you don't have to worry about those because they come from another library, leap4, where they're not going to use actually. Anyway, the thing that you will need to do next is to generate the project. And after doing that, then in the same folder, in the out folder, then you will be seeing the Visual Studio project. So, and that is the outcome of this. So we'll be seeing a solution that you could also open. So quickly enough, then you could just say open the project, and then Visual Studio will be pop up. So now it's loading all the stuff that we need. And the thing that you will be seeing in here is that you have a lot of projects here and you have all built. So that is also including the master degree course. But the thing that you will need to use is just to set up as a startup project the Numerical, and then you could test to build it just to check if it is working properly. And as you see, it's just building everything as you're supposed to be in a usual Visual Studio environment. While we wait, we'll also show about a bit of the code. As you see, you have the same structure that you're accustomed to, so you have header and source, and then the numeric error is just the entry point of the program, so that will be this one, numeric error, here. And so these are all the functions associated with a project that are going to print and visualize the thing that we were describing before. So after building everything, the thing that you could do is just to run the project itself, numeric error, and you will see actually some output. So that means that everything is working fine. In the actual tutorial, given that the code is actually the same, I'm just going to show everything using CLion in a Linux environment, but after knowing how to port everything on Windows, then you'll also be able to follow the thing that I'm showing you on Linux also in a Windows environment. Thank you.